Good morning students. Welcome to our online video class of chemistry. I hope all of you are doing well and safe. Let's recall what we learned in our previous class. In our previous class we learned about chemical reactions and also study about how to formulate a chemical equation. Today we are going to study about balancing of chemical equation. Examine the equation given. This is a chemical equation of chemical reaction between iron and steam. When steam is passed over heated iron, we get magnetic oxide of iron and hydrogen. Is this chemical equation is balanced? How do we find out a chemical equation is balanced or not? How to balance a chemical equation and what is the need for balancing a chemical equation? Because every chemical reaction must obey law of conservation of mass. Let's recall what is law of conservation of mass that you have learned in your previous class. Mass can neither be created nor be destroyed in a chemical reaction. That is, the total mass of elements present in the product should be equal to the total mass of the reactant after the chemical reaction. That means the number of atoms of each element in both right and left hand side must be equal. Now we can say by using law of conservation of mass whether the equation is balanced or not. For that, let us examine the number of atoms of each element present both ends side of the equation. Let's check whether the iron atom is balanced or not. In left hand side, the number of iron atom present is 1. In right hand side, the number of iron atom is 3. So, the iron atom is not balanced. In the case of hydrogen, there are 2 hydrogen atoms present in left hand side and 2 hydrogen atoms present in right hand side. So, hydrogen here is balanced. But oxygen in right hand side is 4 and in left hand side is 1. So, hydrogen is not balanced. So, the equation is not balanced according to law of conservation of mass. Because the number of atoms of each element in left hand side is not equal to right hand side. Therefore, by using law of conservation of mass, the equation is not balanced. Next, we are going to balance this equation. First step is write the skeletal chemical equation. That is Fe plus H2O gives Fe3O4 plus H2. Then draw boxes around each formula. That is shown here. Do not change anything inside the box while balancing a chemical equation. In the next step, we are going to list the number of atoms of different elements. How many elements are present in this equation? There are 3 elements. What are they? Iron, Fe, hydrogen H, oxygen O. Then we are checking how many atoms of elements are present in left hand side and right hand side. In left hand side, only one iron atom is present. In right hand side, it is 3. In left hand side, 2 hydrogen atom is present. In right hand side, 2 hydrogen atom is present. In the case of oxygen, the number of oxygen present in left hand side is 1. And in right hand side, the number of oxygen atom present is 4. Then we are going to select the biggest formula. Which is the biggest formula here? Fe3O4. And balancing the number of element with highest number of atom. Here, the element with the highest number of atom is oxygen. There are 4 oxygen atoms present at product site. So, in order to balance oxygen atom, we have to multiply the water H2O with 4 on left hand side. Equation become Fe plus 4H2O gives Fe3O4 plus H2. Now the equation become balanced or not? Let's take. The number of iron atom present on LHS is 1 and that of RHS is 3. So here iron is not balanced. In the case of hydrogen, there are 8 hydrogen atoms, that is 4. H2 means 4 into 2, that is 8 hydrogen is present here. And in right hand side only 2 hydrogen is present. So hydrogen is not balanced here. But oxygen is balanced. Both right hand side and left hand side contain 4 oxygen atoms. The above equation is again not balanced. So, in order to balance the iron atom, we have to multiply the iron atom on left hand side with 3. So, the equation becomes 3Fe plus 4H2O gives Fe3O4 plus H2. Now, the iron atom and oxygen are balanced. What is remaining here? Hydrogen. In this equation, hydrogen is 8 on left hand side and in right hand side there is only 2 hydrogen atom. So, to make hydrogen on right hand side has 8, what we have to do? Multiplying it by 4, because 4H2 means 4 into 2, that is equal to 8. Here. Then the equation becomes 3Fe plus H2O gives Fe3O4 plus 4H2. Then here there are 3 Fe atom on LHS and RHS also 3 iron atom. In the case of hydrogen, there are 8 hydrogen atom on LHS and here also in right hand side 8 hydrogen is present. Another example. This is the reaction between magnesium and oxygen. Magnesium react with oxygen gives magnesium oxide. Then this is the chemical equation of the above reaction. Mg plus O2 gives MgO. The substance which is present on left hand side is reactants, and the substance which is present on right hand side is products. Then let's check whether the equation is balanced or not. According to law of conservation of mass, the number of atoms of each element present on LHS must be equal to RHS. Let's check. How many elements are participating in this reaction? 2. What are they? Magnesium and oxygen. First we are going to check whether the magnesium is balanced or unbalanced. Magnesium on LHS is 1. And number of magnesium atom present on RHS is also 1. Here magnesium is balanced. Next we are going to check whether the oxygen is balanced or unbalanced here. The number of oxygen atom present on LHS is 2. And that of RHS is 1. From this we can say oxygen is not balanced. Therefore, according to law of conservation of mass, the equation is not balanced. So we have to balance the above equation. The first step for balancing the equation is writing the skeletal structure. That is Mg plus O2 gives MgO. Then draw boxes around the formulas. And this method is called the hit and trial method. That is drawing boxes around the formula. That method is called hit and trial method. In this next, we are going to list out the number of atoms of each elements on LHS and RHS. What are the elements present in this equation? Magnesium, oxygen. How many magnesium are there on LHS? We already find out it. 1. And in the case of RHS also 1. Number of oxygen atom is 2. And in RHS 1. So we have to balance oxygen. To balance oxygen, we have to multiply it with 2. Then the equation becomes Mg plus O2 gives 2MgO. Why does we write here 2MgO? Because to equalize number of atoms, we cannot alter any formulas inside the box. So we can write it as 2MgO. We cannot write it as MgO2 or like this way, or MgO twice. This is wrong. We can only write in this way. And we can only put 2, the coefficient 2 as 2MgO. And let's check whether the equation is balanced or unbalanced now. How many magnesium atoms are present here? 1. And oxygen is 2. Here in RHS, how many magnesium are there? 2. Oxygen is 2. Here oxygen is balanced, but magnesium is not balanced here. So in order to balance magnesium, we have to multiply it with 2. Here on LHS, magnesium is not balanced. So we are going to multiply the magnesium on LHS with 2. Then the equation becomes 2Mg plus O2 gives 2MgO. Now it become balanced. Let's check. How many magnesium atoms are there? 2. And how many oxygen atoms are there on LHS? 2. And on right hand side, the number of magnesium atom is 2 and oxygen atom is also 2. Hence, according to law of conservation of mass, the number of atoms of each element on LHS equal to RHS. So we can say the equation is chemically balanced.
Examine the equation given. We have already seen this equation and we also balanced it. The equation is 3Fe plus 4H2O gives Fe3O4 plus 4H2O. Does this equation tell us anything about the physical state of each reactant and product? No information has been given in this equation about their physical states. To make a chemical equation more informative, the physical state of reactant and product are mentioned along with their chemical formula. The gaseous state is represented as G and liquid as L, solid state as S and aqueous state as AQ. Now we can write the equation as 3Fe solid plus 4H2O gas equal Fe3O4 solid plus 4H2 gas.